So here's an example. We'll look at number 75 here. This is from the book on page 337. And so I want to show you this one because we have a negative leading coefficient. Whenever your leading coefficient is negative, you want to factor out a negative. You want your GCF to be negative, okay? And so I'm going to put a negative on the outside right off the bat. And then I want to think about, okay, what's the largest number that goes into 2 and 18? And that would be 2, right? So I'm going to put a 2 out here. And then they don't share a variable, so there aren't going to be any variables with the 2. It'll just be negative 2. So I'm going to put my leftovers back inside, right? So what that means is I'm going to divide each of these terms by negative 2, right? I'm basically undistributing, right? I'm dividing this term out. We're doing the reverse distributive property, so instead of multiplying, we're dividing. And so what will happen is the negative 2's cancel out to positive 1. The x squared comes down. Here, 18 divided by negative 2 is negative 9. So I bring a negative 9 down, right? Okay. And so now I have negative 2 times the quantity of x squared minus 9, right? But remember, we want to factor completely. And so we want to look at, okay, what's inside here, and is it something that we can factor? And it turns out it is, right? It's a binomial. So remember, if it's a binomial, we check, okay, is it a difference of squares? And it turns out it is, right? This is a perfect square. This is a perfect square. It's a difference. It's a binomial, so there's 2 of them. So it is, in fact, a difference of 2 squares. Okay, so we can factor this out. So we're going to do this. We're going to take the square root of x squared. That's x, so that goes here and here. We're going to take the square root of 9, which, remember, not the square root of negative 9, just square root of 9, and that's 3. That goes here and here. And now we'll account for the negative, right? In order for it to be a negative, we would have to have a positive 3 and a negative 3 multiplied together, right? So that's how we get negative 9, is when we multiply positive 3 by negative 3, and that gives us negative 9. Okay? All right, and so that's it. This we can't factor anymore. This we can't factor anymore. They're not perfect squares. This is a difference, but it's not of squares. So that's as far as we can go. All right, so a couple things. First of all, remember, when you start with a leading coefficient that's negative, you factor out a negative. Okay, so notice these other questions, we wouldn't have to factor out a negative, right? Because our leading coefficient is positive. So only when your leading coefficient is negative do you need to factor out a negative. And when you do factor out the GCF, notice that here we couldn't do anything with that, right? 18 is not a perfect square. 2 is not a perfect square. So we couldn't factor that, right? So until we factor out the GCF, were we able to get to something that we could factor, right? So that's just one indication of why it's important to factor out the GCF. Okay. The other thing is that we end up with smaller numbers, right? Instead of 18, we're dealing with 9, right? So when you factor out a GCF, you're going to end up with smaller numbers after you divide. And so that's another advantage of factoring out the GCF. Let me show you one more with a negative leading coefficient. Let's take a look at number 81 here. So here I have a negative 5 as a leading coefficient, right? So I know my GCF is going to be negative. And then I look through these terms, 5, 50, 125. 5 is the biggest number that goes in all of them, right? So 5 is the GCF. There's no variables that they have in common, so it's just negative 5. My leftovers, after I divide everything by negative 5. So remember, when you divide by a negative, just like we saw in the last one, your signs are all going to change, right? So this is going to turn to a positive. These will cancel out, right? So it'll be a positive y squared. This will turn to a negative, right? Positive divided by negative is a negative 10y. 50 divided by 5 is 10. And then negative 125 divided by negative 5 is positive 25. Okay? So we factor out the GCF. Now we want to look at this inner term here and see, is that something that we can factor out more? And the answer is yes, we can, right? Like it's a difference of, or excuse me, it's a perfect square trinomial, right? This is a perfect square. This is a perfect square. If we take the square root of them, we get y and 5 times y doubled is 10y. So that works. So now I can turn it into something like that, right? So I take the square root of y, and that, or square root of y squared is y. Square root of 25 is 5. And then remember that this term, or excuse me, the sign of the middle term is always the sign that comes down and is in the middle of your binomial down there. Okay. All right, so that's our final answer. Okay, remember that this means y minus 5 times itself, right? Y minus 5 times y minus 5. It does not mean that you can distribute the 2 to each of those terms, right? It's not y squared minus 5 squared. That's not the same thing. Okay, keep that in mind.